Hello everyone, welcome to this first section of the study of wave motion. This section is an introductory section and we are going to approach this study through 5 lessons. The first lesson where I'm going to start introducing, using and explaining different concepts that we need for the study. In the second lesson, what I'm going to do is to list the different classifications and explain which ones we have to do the analysis of wave motion. The third lesson, where I am going to study perhaps the most outstanding magnitudes that we always use in the definition of the characteristics of the waves. I will continue in lesson 4 with an analysis of the equation of a wave, and finally what I will try is to give some examples as everyday as possible to apply everything we have learned in the previous 4 lessons. Starting with this first lesson, I will begin with a definition or an approximation to a definition of a wave motion when waves are produced, and I will introduce vocabulary such as what we mean by a periodic motion, oscillatory motion, vibratory motion, and throughout the lesson what I want is to analyze different examples or different situations where phenomena are occurring, where the propagation of wave phenomena occurs. Where does the definition of a wave come from? Well, the definition of waves or wave motion arises from the observation of phenomena that occur in the media when they are disturbed. A first definition we can have of a wave is the disturbance of the medium that propagates within the same medium. And one of the most beautiful phenomena that arise when disturbing the medium that surrounds us is given by these young artists that if we listen to them, we will be able to see right away what it is all about. This young artist is disturbing the air inside the tube of the clarinet, and he is also disturbing that tube as it affects the propagation of the disturbance that he generates as modifying. We see how his hands are moving and how he is modifying that tube, and this young artist is also capable of producing disturbances. Let's see how. In this case, the disturbances that she is producing are directly with her bow and disturbing the strings of her viola, but she is also disturbing those strings by manipulating their length with the pulsations of her fingers. In this case, we introduce already vocabulary that we are going to use. On the left, we have a generation of longitudinal waves. On the right, 2 types of waves are being generated at the same time. Longitudinal waves as here that are sound waves, and also transverse waves that are being produced in the strings of the viola. All this we will be approaching little by little, and we will be having it more and more clear. There are many examples around us that if we accompany our friends Jota and Amanda in the observation of everything that happens in nature, we will find propagation of wave phenomena and wave propagation. Propagation of wave phenomena, examples of which are we have them in the waves that are produced on the surface of the sea when we analyze the oscillations of the pendulums of the clocks. When we sing or talk simply as I am doing now, we are generating sound waves that are transmitted thanks to the fact that I am inside the material medium and I am changing the density in different parts of the medium, the density of air. And those same waves are able to reach someone who wants to listen to me. In this case, Jota is listening to Amanda singing. We also have disturbances that propagate on the surface of a pool of water. For example, in this case, there is an impact of water droplets, but there can also be an impact of a stone that we throw. And we also have that same generation of waves that we can generate in a rope, also the light waves that are generated if we want to illuminate a room. Later, I will show you some other example. And in experiences as different as analyzing the heartbeat or how are the vibrations of the atomic nuclei or of the atoms in the structures of the materials, we find that same generation of wave phenomena. We have to take into account that then a wave is a disturbance that propagates in a medium. What is actually propagating is an energy along the medium. If we take into account, for example, the undulations that are made on a surface, the ripples that are being generated on a surface of a liquid. What is propagating is that wave motion. But if we try to test what is being propagated through these balls that have been left as floating in the medium, we see that these balls always occupy the same position. What propagates is that perturbation, that energy associated with the wave motion. Then from now on, what we have to take into account is that the propagation that takes place is of an energy. That energy can propagate with the wave that we generate in a rope. It propagates with the different pressure waves that are generated when we are talking. In this case, Amanda is singing. Or we also have, in this case, electromagnetic waves and electromagnetic energy, then that propagates with light waves, for example, or any type of electromagnetic radiation. That same analysis of propagation can be seen through these animations where we have a spring, in particular this spring that I have here, and a colleague is helping me to generate different types of waves. We have that through a pulsation, and this we can see it left here directly, I am the emitting focus, and I am with my right hand generating a perturbation. I can make another very different type of perturbations, and I generate two types of wave by introducing vocabulary. Longitudinal wave, we will see why. Transverse wave, the perturbation, I am producing it in a very different way, as we see in these two reproductions also. What I want also to see a little bit, the effect that the propagation that is taking place is of energy and not of matter, of the medium. I want to analyze this mechanism that I have brought. Look in this mechanism, what I have are 5 little balls. It would be the medium, and I am going to cause a disturbance. What kind of disturbance am I going to cause? Well, as always, when I cause a perturbation, it means that I take the medium out of its equilibrium position. I take one of the balls, I separate it from its equilibrium position, and I let it oscillate. What are we seeing? I can stop it. What I do is I take a ball and I lift it, I communicate potential energy to it, and I am going to release it. When I release it, little by little, it will accelerate, it will increase its velocity. Until it impacts, what I am doing is to increase the speed and therefore the kinetic energy that will be communicated to the balls. We see that 2, 3, and 4 of the balls barely move. Because what they do is to transmit along them their energy that reaches the last ball. I can keep the potential energy of this ball and stop the perturbation. Then what is transmitted is not the balls. The balls move the minimum, and what we see moving simply because of the shocks that are occurring. But what is being transmitted from one end to the other, end of the middle of the 5 balls, is the energy. Okay? Okay. With this experience, I think it's very clear to us. Continuing with all the concepts that I want to introduce, I want to distinguish along generating this disturbance between the movements that we are going to find and distinguish between periodic motion and oscillatory vibratory motion when the movement is periodic. Well, a movement will be periodic when it repeats itself at equal intervals of time. For example, the hands of the clock are always describing the same type of circular trajectory. Also in this case, Jota is producing circular trajectories with the ball with which he is playing. I want the trajectory of that ball to be represented here, but in an oscillatory movement, it does not have to be a circular movement. In the oscillatory movement, what I am going to have is that I am taking the system out of its equilibrium position, and in that case, it is going to oscillate from one side to the other with respect to that equilibrium position. I have that movement in the metronomes, in the pendulums like here and here, or also in the vibration of the membranes of the drums. So that we can see and analyze a little bit more this variation that is occurring in the position of the particles of the medium and the propagation of the wave. I am going to take advantage of this simulation where we have what could be the wave that is being generated in the string with which Jota and Amanda are playing. And in this case, I can take this profile and analyze how the wave is propagating. But I can even analyze the movement of each of the sections of the rope that I can represent a little bit by these little balls that I am coloring. And I see in this case how the trajectories follow the same position on the abscissa axis On an x-axis, we could call it oscillate up and down. It would be a type of wave of those that we call transverse waves. But I can change the type of wave to a longitudinal wave. In this case, this would be the movement or even a combination of the two. And here, we would have the origin of the waves that are originating on the surface of the sea. Here we have a small introduction of everything that is happening to us. To finish, I want to call the attention of how important is the environment where the disturbance is taking place. I have brought this mechanism, which is that of a music box, and look how the sonority changes. The effect that we have from this disturbance, the mechanism here in the air, and here I would have it near the microphone, or what I do is to simply rest it on my wooden table, We see how the sonority changes a lot. Or outside. Very well. As an introduction, just to highlight some of the points that I have commented, I want to make it very clear that a wave is the propagation of a disturbance. We must not confuse the propagation of the particles of the medium or of the part of the medium that I am analyzing with the propagation of the energy. What propagates in the wave movement is the energy. We will be analyzing, and we have infinity of different wave phenomena. And we are going to see different characterizations that we can find the limit beta, the phenomenon. We will continue in the next lesson. Thank you very much.